Hi, my name is Tyler Banks, and I will be going to Georgia Tech's 2009 Challenge program during the summer. Yeah, challenge. And today's topic will be limits. Now, first off, does anybody know what a limit is? Ooh, I know what a limit is. Ain't that when you push me too close to the edge, and then you didn't push my buttons too far, and therefore you didn't push my limits? No, actually, I'm sorry. You're thinking of a different type of limit. But thank you anyway. A limit is basically finding the y value of a function at a certain x coordinate. Now, in a function, every x value has to have a corresponding y value, right? So therefore, if a limit is only the y value, then every function has a limit, right? Wrong. Actually, I can think of three cases where that is not so. One, when a function differs from left to right, as seen. As you can see, the function has a different y value coming from the left side than it does the right side at the point x equals 2. Also, when a function oscillates, does a lot of crazy stuff in there, it also does not have any limits. And one more time is when there is a vertical asymptote, or any asymptote for that matter. That's when a function increases or decreases without bound. So I know you may be thinking to yourself, when will a function have a limit? Well, in order for a function to have a limit, it must have continuity. Now, does anyone know what a function needs to have in order for it to be continuous? In order for a function to have continuity, it must first be defined at point f of c. Second, the limit as x approaches c of f of x must exist. And third, the limit as x approaches c of f of x must equal f of c. This basically means the limit value must equal the function value. Well, thank you for that. In order for a limit to be continuous, it basically means it just has to be fluent. Like no weird motions going on. Just one straight thing. No vertical asymptotes and no holes. Now, despite the fact that when there is a vertical asymptote, at that point, you don't have a limit. You may have a limit, however, when you approach that point from either side. Now, as we take a look at this picture, when you approach the limit coming from the left-hand side, it seems to go up to positive infinity, and therefore the limit as it approaches that point from the left-hand side is infinity. But when you're coming from the right-hand side, it seems to go infinitely down. Therefore, as you approach that point from the right-hand side, the limit is negative infinity. These are known as infinite limits. Now, how do you know when you are needed to find the limit as it approaches a specific point from the left-hand side as opposed to when it approaches that point from the right-hand side? Now, they have different symbols for this. Now, let's say this point on this graph is negative 2 that we were just looking at. Now, if you want to find that point, the limit on that point as it approaches it from the left-hand side, you would say negative 2 to the negative exponent. And if you want to find it from the right-hand side, you would say negative 2 to the positive exponent. Like so. These are how these symbols are identified. Now, some of you may be asking yourself, how will you know when there's a vertical asymptote or not? Well, if you have a problem with a fraction in it, and you have an x in the denominator, whenever that denominator is going to become 0, the value for x at that point will have a vertical asymptote. Now, there is one basic part of limits that you have to understand in order to comprehend, and that is called the sandwich theorem. Now, does anyone know what the sandwich theorem is? It's just two basic problems. Does anyone know them? I do. I know the sandwich theorem. Well, can you tell us a little bit about them? Well, sure I can. First off, the sandwich theorem is just two basic problems, and they consist of the limit as x goes to 0 of sine x over x, and that's going to equal 1. That's one of the basic problems. Also, the other basic problem is the limit as x goes to 0 of 1 minus cosine x over x. That will always equal 0. These are the two problems of the sandwich theorem. I love the sandwich theorem. Makes me hungry though. Well, thank you for those interesting facts. You can go take a seat now. Well, those are the basics of limits. Now let's give our cast a round of applause. Mr. Cluck, thank you for stopping by. No problem. And Mr. Lamb, he did very fabulous, I might say. And also, last but not least, Mr. Pig. He did an excellent job of teaching us the sandwich theorem. It was all my pleasure. Well, that's basically it for today. Class dismissed, and oh yeah, I'll see you guys at challenge. Thanks.